Welcome to my presentation on the integration of the Dirac equation in the T0 model. Today I'll show you a revolutionary approach in theoretical physics, deriving all constants from energy principles without free parameters. As you can see in this thumbnail, energy, symbolized by Einstein's famous equation E equals mc squared, forms the central foundation of our theory. Two complementary models, the T0 model with its time field and the ESM with its scalar field, are connected through a logarithmic relationship and deliver identical, precise predictions that perfectly match experimental measurements. Integration of the Dirac equation in the T0 model, energy-derived constants lead to precise predictions without free parameters. This work represents a significant advancement in theoretical physics, demonstrating how fundamental natural constants can be derived directly from energy principles without arbitrary adjustments. The key insight of our research is that all constants within the model can be derived from fundamental energy relationships, leading to a consistent and predictive theory. Energy is the fundamental foundation of all physical constants in our approach. On this slide, you see a comparison of both models. In the T0 model, kappa natural and R0 are derived directly from energy principles, while the time field T, x, t, represents the fundamental field quantity. In the parallel ESM, kappa and the gravitational constant g are also derived from energy principles, with the scalar field theta as the basic quantity. The crucial point is, both models operate without freely adjustable parameters. The logarithmic relationship at the bottom of the slide shows the mathematical connection between both formulations. The mathematical equivalence of our two approaches becomes visible in the modified Dirac equations. On the left, you see the T0 model version with the time field T, xt, which defines spacetime and enters into the gamma matrices and connection terms. On the right, the ESM version, where the scalar field theta modifies the dynamics through an additional term in the derivative operator. Although the mathematical representations appear different, they describe the same physical reality, as both are based on identical energy principles. This consistency is a strong indication of the correctness of our fundamental approach. The acid test for our theory is the precise prediction of measurable quantities. Here you see the results for the G2 factor of the electron, one of the most accurately measured quantities in physics. Our T0 model predicts a deviation of -0.89 plus or minus 0.05 times 10 to the power of -12, while experimentally a value of -0.88 plus or minus 0.36 times 10 to the power of -12 was measured. The ESM delivers the same result. This extraordinary agreement, within just 0.03 standard deviations, was achieved without adjusting any free parameters. It is a direct consequence of our energy-based constants and represents an impressive confirmation of our approach. The conventional approach of the standard model and its extensions typically uses more than 18 freely adjustable parameters that need to be fitted to experimental data. This is conceptually unsatisfying, as a fundamental derivation of these parameters is missing. The decisive advantage of our T0 model and the ESM lies in deriving all constants directly from energy principles without freely adjustable parameters. This common foundation ensures mathematical consistency and leads to identical predictions despite different formulations. The central insight is, when constants are correctly derived from energy principles, different mathematical formulations must converge to the same physical reality. In conclusion, we have shown that both the T0 model and the ESM derive all their constants from energy principles, leading to precise predictions without the need to adjust free parameters. Although the mathematical formulations are different, they describe the same physics. The implications are profound. They confirm the fundamental role of energy in physical laws, eliminate the need for parameter fitting, and point to deeper unifying principles in physics. Our conclusion is clear: energy is the ultimate foundation of physics. When constants are derived from energy principles, different theories naturally converge to the same precise predictions. Thank you for your attention. I hope this presentation has given you a good insight into our approach to integrating the Dirac equation in the T0 model and demonstrated the power of energy-derived constants. I now look forward to your questions and an engaging discussion about the implications of our results for theoretical physics and the deeper understanding of fundamental laws of nature.